This is the Math 1111 Zoom meeting for 9 p.m. Monday, November 16th. I did a pretty thorough intro to 4.4 and 4.5 for this week, so won't repeat that. We'll just work some problems down through. We'll start on 4.5, page 404, say at number 5. 5 to the 2x minus 3 equals 1. And again, if you're really slick, you can make this 5 to the 0. That would put 2x minus 3 equals 0 and play it that way. But it only works on this exact problem. So I try to use methods that work every single time. So I'm going to use ln. A 5 to the 2x minus 3 equals ln of 1. Which means I get 2x minus 3 to the front, ln of 5 equals ln of 1. Remember, ln of 1 is always 0. You can punch it and see. So that's 2x minus 3 ln of 5 is equal to 0. I divide by ln of 5. That gives me 2x minus 3 equals 0. ln of 5 just some nasty decimal, so 0 on top is going to stay 0, which means 2x equals 3, and x is 3/2. And this is always legal. If anybody watched the 12 p.m. video on log equations, you have to watch and make sure your answers do not put a 0 or a negative into a log when you check back. But you can check this. 5 to the 2 times 3/2 minus 3. If you distribute the 2, you get 5 to the 3. I'm sorry, that's 2 times 3. It's not distributed. It's 2 times 3/2 minus 3. So it's 5 to the 3 minus 3, which is 5 to the 0, which is 1. Because your 2's cancel. 3 minus 3 is 0. 0 power is always 1. All right, why don't we try something further down like 15. I'll start on the top because these could get long. 404, 15. 1 minus x equals 3. This sort of illustrates why people don't mess with other bases, because if you use the log base 2 here, yeah, you can cancel this, but it won't that. If you use a log base 3, you can cancel it, but it won't cancel that. And you can't use log base 2 here, log base 3 here. You're violating whatever you do to one side, you do to the other. So don't use any of it. Use ln. So ln of 2 to a 1 minus x is equal to ln of 3. 1 minus x, ln of 2 is equal to an ln of 3. I, in any case, usually like to divide by the ln of 2. Minus x equals ln of 3 over ln of 2. Negative x equals ln of 3 over ln of 2 minus 1. So if we divide by negative 1 divide everything by negative 1, you get a positive 1 minus ln of 3 divided by ln of 2. Now that's the answer to A. If you notice there's an A, the exact answer. B, they want an approximation. So x equals, if I can find a calculator. One minus ln of 3 and divide by ln of 2. Negative 0.58. When they say 6 places. 4, 5, and it's a 5, so that should be rounded through. So negative 8, 4, 9. If I be 7, that'd be 5 places. So 6, 3, I think. There's the 6th place, the 5 is bigger, so that should be rounded to a 3. I'm not that anal about it. I won't rip you or make it true or false based on that kind of thing. I'll make it a lot more obvious than that. All right. Oh, let's see. I think I did 27. I think I remember doing 27. Well, maybe I should do another quadratic type. 41. And e to a 4x, add 4e to a 2x minus 21. If you watch 12 p.m. video, when this is double, that power doubles this. It's a quadratic form. And you can factor it as an e to a 2x and e to the 2x. And we need two numbers multiply two numbers. They multiply negative 21 actually, and add 4. That's probably going to be a 7 and a 3. And the 7 is going to need to be positive. 3 will be negative. Okay. You can FOIL back e to a 4x because the powers add. A negative 3 to 2x adds 7 to positive 4 and a minus 21. So then if you want to call this factor 1, factor 2, or piece 1, piece 2. So for factor 1, e to a 2x is equal to a negative 7. This should tell you there's something funny going on. Take a log of e to the 2x equals log of negative 7. No solution. You can, if you forget that, you cannot use 0 or negative into a log. If you forget it, you can go log negative 7 and error. No real answer. So that's got no solution. Nothing for x out of this. Take piece 2 though, e to the 2x equals 3. Log e to the 2x equals log 3. You could put the 2x in front, but you don't have to. These do directly cancel. 2x equals log 3. Be log 3 divided by 2. That's the exact. They asked for exact. No, they just said solve it. Okay. So if you wanted an approximation, you would take ln 3 and you divide. That's not a negative. That's a blip on my screen. That's not a negative 3 there. It's a blip on my screen divided by 2, and you would get 0.5493. That was going to be the only answer out of that. We can try one like 47. 4x cubed e to a negative 3x minus 3x to the 4th e to the negative 3x. Does this gibberish make you want to go, why did I sign up for this class? All you want to do is factor out the common factor. All right, 3 and 4, nothing common there. It'd be x to the 3rd and the e to the minus 3x minus 3x, big parentheses. All right, so you'd be left with 4. So if I'm left with the 4 and I'm just it all writes together and gives you this minus 3. You pull that x to the 3rd, that will leave you an x, and e to the minus 3x pull that. So it'll leave you like this. Minus 3, x to the 4th, when you combine those, and e to the negative 3x, when you multiply that. Basically, you've got 3 pieces with number 1, piece 2, piece 3. Each piece set to 0. So piece 1, x cubed equals 0. X has got to be 0. Third root. Explained at 12 o'clock today, if I go e to the negative 3x equals 0 and do a log of 0, this has no solution. you can punch it, so just exactly like the log of -7 up here, no solution. Any exponential equals 0, there's no x value that does that. And 4 minus 3x equals 0. 4 would equal 3x, divide by 3, and your x is 4/3. So you're getting two numbers out of this. X is 0. You can see the check for that. If x is 0 there, that kills that. If x is 0 there, kills that. Equals 0. 0 minus 0 is 0. The 4/3, you have to punch in, sub in and punch. All right. Still on page 404. How about ones like, I can't remember if I did 51. I did 49. I don't think I did 51. These are log equations. Twice log of x, log of 2, log of 3x minus 4. All right, I'm just going to make this log of x squared. And I can combine, make that a log of 2 times 3x minus 4. Then I want to raise 10 to the log of x squared, 10 to the log 2 times 3x minus 4. So that this undoes. X squared then is equal to 2 times 3x minus 4. So that will give me x squared equal to 6x minus 8, which gives me x squared minus 6x add 8 equals 0. I believe you're going to find that's x minus 4 and x minus 2. X squared minus 2x minus 4x is your minus 6x, and -4 times -2 is your positive 8, giving us x equals 4 and x equals 2. And I'm just in my head, I'm checking if both x equals 4 and x equals 2 make the logs positive, strictly greater than 0. Can't even use 0. And I believe they do. Twice a log 4, x equals 4. That's twice log 4 equals log 2, log minus 4. This is 8, so that's positive, and x equals 2. I get twice log 2, log 2, log 3 times 2 minus 6 minus 4, which is 2 positive. Yes, both equals 4 and are legal answers. 4x equals 2. Jerking them off too quick. On to the next one. All right, why don't we try something like 65? Log base 9 of x minus 5. Log base 9 of x plus 3 comes up 1. We can combine. This will give us a log base 9 of x minus 5, x plus 3, 1. Use 9 as a base. 9 to the log base 9 of x minus 5, x plus 3. 9 to the 1. This is why you got to do both sides. You know, you might be thinking, gee, what do you get? Of course, you know, this is going to equal this because you got a log on both sides. Yeah, but I do like to show this step because on a problem like this, you may not realize you're going 9 to this, but you're also going 9 to the 1 to do the same thing on both sides. So only one side really undoes, and you wind up with x minus 5, x plus 3 comes up 9. A lot of people leave that 1 and then wonder why they get the wrong answer. Okay, so yeah, it's very important to know you're undoing what's shown and you're doing the same thing to both sides. Y'all good foilers? 3x minus 5x and minus 15 minus 9 equals 0. You want everything to one side because you get squares, letters, numbers. It's going to give you x squared minus 2x and minus 24. And that's going to give you x minus 6 and x plus 4. Plus 4 minus would be negative 2 and minus 24. And that's going to give you an x is 6 and x is negative 4. Are these legal? Well, x equals 6 is log base 9 of 6 minus 5. Let's see, that's positive. Plus log base 9 of 6 add 3. See, that's 9. That's positive. It's supposed to come up 1. All right, but x equals negative 4 is not legal. You have log base 9 of negative 4 minus 5. That's negative 9. You don't even need to check the rest of it. But you can, it doesn't work in this one either. It gives you negative there, but that doesn't matter. Even one spot where it's illegal. See, there's no finite number coming out of this that could possibly check. So x equals 6. Only answer. You have to watch for that. All right, why don't we try one more? How about one like 66? ln of x minus 1, ln of x plus 2 comes up 1. Again, you can combine x minus 1 times x plus 2 comes up 1. You see, this is not a case of doing something on one side and not something on the other. This is an equivalent expression to this. It was law number 1 of logarithms. So you can replace this with this, perfectly legal, without doing anything on the other side. These are equivalent expressions. All right, use base e. E to the ln of x minus 1, x plus 2 equals e to the 1. Similar to last problem, so this base e. 9. All right, so that means x minus 1, 2 equals e. So that is x squared plus 2x, round 1, minus x minus 2 minus e. This is not going to be a real clean quadratic here. Plus x minus 2 minus e equals 0. Looks like we're going to have to use the quadratic formula. A is 1, B is 1, and C is a negative 2 minus E. So let's see, x would be negative b, add and subtract, square root b squared, well, that'd still be 1, times a is 1, times c is negative 2 minus e, over 2a, which is 2. About the only thing you can do, I don't know if they leave in terms of e or if they get a cap, maybe we'll leave in terms of e. All you can do is negative 1, add and subtract, big square root, 1. You factor out your mind, you're going to get a plus 4 times 2 plus e. Or you can take that negative through, and it turns everything positive there, and it's still all over 2. X is then negative 1, add and subtract, big square root, 1 plus 8 plus 4e, all over 2. Oops, negative 1 plus or minus square root of 9 plus 4e, all over 2. Let me look this one up. Oh, it's even, dadgum. Well, so you could approximate this. Negative 1 plus square root 9 plus 4 e1, and divide that by 2, 1.72896. And you can go negative 1 minus square root 9 plus 4 e1, and divide that by 2, and you're at negative 2.72896. So yeah, a little nasty one. Didn't work out real clean. All right. Why don't we try a few problems from section 4.6. I think I worked number 1 at 12 today. So why don't we, page 414, try one like number 3. About a gray squirrel population. So this one right here. Introduced into a certain county of Great Britain. Population doubles every 6 years. Population is now 100,000. What was the initial size? Okay, notice that doubling. They are using this doubling formula. So part A equals n02 to the t divided by A. A equals doubling time. N0 equals initial time. Okay. In 3, the doubling time is 6 years. Now, population, wonder how they know it's 100,000. Somebody sit down literally and go 1, 2, 3, all the way up to 100,000. So strange what they think they know. Okay, what was the initial size? Okay, what was the initial size? That'd be in 0. In other words, find in 0. So you'd have 100,000 in 0 to t is 30 over 6. Now, where did 30 come from? Well, 30 years ago, so presumably 30 years later, your population's 100,000. So at 30 years, your population is 100,000. So t equals 30, and your population's 100,000. So 100,000, 2 to the 5th. Well, 100,000. 2 to the 5th is 32 in 0. So I'm going to divide both sides by 32. 100,000 divided by 32. $31.25. Must have been 3,000 squirrels. Estimate the squirrel population 10 years from now. Find n in effective 10. So that would be 3125 times 2 raised to the 10 over 6. Now, let's see, 10 years from now. Actually, that would be 40. Maybe I better double check this one. 10 years from now. Years from now. Now is 30 when they introduced it. So I'm thinking that should be 40. I'll run this and then we'll check it just to make sure. Thinking about it right. 3125 times 2 parentheses 40 divided by 6. Well, that's a lot of squirrels. 317,480. You really don't need the decimal because who cares about 0.2 squirrels? Maybe we better, 10 years from now, I'm thinking this whole scaling should be 40. Maybe I'm overthinking it. Let's find out. 4, 5. 4, 6, number 3. Okay, got the 3125. Got the 3125. 317,480. Yeah, there you are, and there's the 317,480. Okay, whew, glad I caught myself. I did make a bad mistake at 12 o'clock. If anybody watched the video, wanted to see me look like an idiot. Let's see, they want a graph. So you'd enter y equals 3125 to the x divided by 6. Trick though is, what the heck, this means you're starting at 31, just to sketch it out, you're starting at 3125 at x equals 0, and then it's going up, and by what, 10 years, it was at 370, oh no, that's 40 years, 15,000. So it's in 40 years. So why don't we, at least to see that point, why don't we go out 0 to 50? So window, let's go out 50, 0, 51. And y is 0 because you don't have negative squirrels. And it went up to 3. Let's go up to 350,000. 1. Okay, so y equals 3125 times 2, the parentheses, x divided by 6, 0, 51, 0, 350 by 1. Yeah. Give you a nice graph. Oh, there it goes. Nice graph. And I think that matches. And it doesn't, on this scale, you can't really see the, since it's going to 350,000, 3,000 doesn't show very well. That's basically 3125 and it's raising up. Yeah, now they're showing it go through the millions of squirrels. So they're going out to 50 years. 0.2 millions is 200,000, 350,000 is up in here. But they're showing it, looks like through the origin, but it's not. You just can't show 333,000 squirrels very well on this scaling. All right. Try let's try number 5, which is a straight exponential. Page 414. Fox population. Growth rate, usually use R. It kind of parallels interest rate, 8%, 0.08. In 2013, the population is 18,000. All right. A, find a function and they tell you it's n of t equals n0. Again, this is the initial amount. E to the RT. It looks very similar to compound interest, but it's does a general growth. Instead of your money growing and compounding, it's population of things that are growing and compounding. All right. So the 18,000, that's going to be the n0. So n of t is 18,000 e to the 0.08 t. T years after T years after 2013. Estimate Fox population 2021. So this is you don't use 2021. This is sort of set up. If T is 0, you end up with 18,000. So T equals 0, that's 2013. So at 2021, you'd be at 8 years. That'd be T equal 8. Use T equal 8. So n of 8 then is 18,000 e to the 0.08 times 8. 0.08 times 8. 34,136. We just use whole numbers since you don't care about point. If you wrote down 0.65, we'd mark it wrong. And I'm not going to go with true or false answer if you use the 0.65. Again, we'll try to make them a lot more obvious than that. After how many years will the fox population reach 25,000? After how years will the fox population reach? Well, it better be before 8 years, because it took 8 years and you got 34,000. So 25,000, a lot less than 34,000. So it's going to be less than 8 years. So we're going to solve 25,000 e to the 0.08 t. It's equal to 25,000, and we're going to unravel it and solve for the t. Let's divide by the 18,000. Zeros cancel. 25 divided by 18. 1.38888, 1.38888. T. Use ln. ln. Maybe I'll leave it 25 over 18, make it more accurate, equals ln of e to the 0.08 t. These will cancel, so ln of 25 over 18 equals 0.08 t. And all I got to do is divide both sides by 0.08. There's my exact, which isn't super helpful. So you want to go ln 25 divided by 18. And then divide that by 0.08. 4.1 years. 41. T equals 4.1 years. Notice much less than 8, as it should be. Okay, sketch a graph of the fox population. Fox population 4 years, 13 to 2021. Again, this will be t equals 0, equals 8. So this is like your x min, x max. T equals 8 worked out, your y worked out 34,136, and t equals 0 worked out 18,000. Right? Yeah. So your window, just arguing out the window, 0, 8, 1, 18,000. Let's make it 35,000 again by 1. This is your x min, max, x scale, y min, y max, y scale. And your formula is y equals 18,000.08x. X window. Oh, make it 8. No, 0, 8, 1. Yeah, you went out for 8 years, and then 18. Could start at 0, but it's really going to look compressed if you do. 18,000 to we said 35,000. Then we saw all we got to do is take out one of those zeros and graph. And there you are. And it's going up, again, starting at 18,000, 0 out to 8. Okay. Well, that's examples of all the problems. We're at 40 minutes, so why don't we go ahead and call it, and we'll meet again on Thursday if anybody wants to join me on Thursday and ask any questions. Right now I'm scheduled for 12 and 9 on Thursday. We'll look forward to seeing you then. Thank you.